Do you remember the last time you went to a clothing store to buy a pair of jeans or a shirt, a salwar kameez set or a sari? From all the thousands of clothes on display, you had to find the one that fit your needs exactly. The right size, right style, right color, and right price. But come to think of it, it wasn't all that difficult, was it? That's because the stores are divided into sections with different types of apparel in different locations, sorted conveniently by size or style into racks and hangers. The same thing happens in Java, but instead of types of clothing, it deals with types of data. Data categorization is a very important aspect of every computer language. There are various types of data: whole numbers, fractions, decimals, characters, text, etc. All these need to be stored in different ways so that they can be identified and their associated operations performed swiftly and accurately. Java stores data in categories called data types. In this session, you will learn about these categories and how to work with them. Broadly, there are two data types in Java: primitive and reference. Primitive data types are inbuilt in Java. They can be grouped into four categories: numeric integral, fractional, character, and Boolean. Reference data types are constructed from primitive data types and include any instantiable classes, arrays, and interfaces. Let us look at the four categories of primitive data types in greater detail. Numeric integral primitive data types are used to store numeric values that are whole numbers only. The numeric integral category includes four data types: byte, short, int, and long. Java does not support unsigned data types, as these include positive numbers only. In Java, you can store all numeric types, negative as well as positive. Fractional primitive data types store fractional numbers, that is, numbers with decimal points, also called floating point data types. The fractional category includes two data types: float and double. Character primitive data types store characters or letters. The character category includes just one data type: char. Boolean primitive data types store Boolean values. A Boolean value has to be either true or false. You need to use certain symbols along with the values to indicate corresponding data types. For example, the suffix small l or capital L is used to indicate a long data type. So 30 capital L would indicate that this is a long integer with a value of 30. Similarly, small d or capital D indicates double data type. Small f or capital F indicates float data type, etc. Take a close look at the displayed table to understand how values are written to indicate data types. Variables are nothing but named memory locations to store values. This means that when you create a variable, you reserve some space in the memory to store a particular value. The values of variables can be changed or manipulated during runtime, that is, during execution of the program. Variables can store integers, decimals, or characters, depending on the data types within them. For instance, you can use the variable marks to store the marks of a student. This variable will be able to store integer or decimal values. You need to declare variables in a program before you can use them. A variable is declared in two parts. The first part is the type name, which can be any Java data type. The second part is your preferred name for the variable, followed by a semicolon. Let's look at some examples of variable declarations. To create a variable called total of the data type int, we need to write int total followed by a semicolon to declare the variable. Similarly, to create a variable called marks of the data type float, we need to write float marks followed by a semicolon to declare the variable. Both these declarations are simple definitions. Simple definitions comprise a type specifier followed by a variable name or identifier followed by a semicolon. Sometimes, you may need to use a data type with more than one identifier or variable. In such cases, list the identifiers one after the other, separated by commas before the semicolon. Once you declare a variable, it is ready for use. You can then assign an initial value to the variable. Initial value, also called default value, is the first value specified while defining a variable. A variable with the first value declared is said to be an initialized variable. Let us look at an example. Here, we are assigning an initial value of 100 to the variable VAL, which is an int data type. We are also assigning a value of 10.5 to variable width, which is a double data type. While writing programs, you will sometimes deal with values that will remain the same throughout program execution. These values are called constants. For example, if you are tracking the marks that students receive in various examinations, then their names are values that will not change. In this case, their names are constants. While programming, it will help you to give names to these constant values. Constants also need to be declared before use. A constant can be declared by adding the keyword final immediately before the data type. The naming conventions of constants follow the same rules as variables, but sometimes programmers write constant names in all caps. This is not a requirement. Once a constant is declared, its value cannot be modified in the program. Let us declare a constant named rate with a value of 0.10. We have to write the word final first, then the data type, followed by the name of the constant and the value. The keyword final will tell the compiler that the value will not change and cannot be modified. Constants provide us with two big advantages. In the first place, it makes the program easy to read and check for correctness. Secondly, if a constant needs to be changed for some reason, for example, a woman may want to change her surname in all her college records after marriage, then all you need to do is change the declaration. You don't need to go through the whole program and search for every occurrence and then change them all individually. This makes the program user-friendly. Now let us look at a code snippet to better understand the concepts we have learned. This code calculates tax on a taxable income of Rs 4 lakh, where the tax rate is fixed at 2%. Here, the data type used is double. The variables are inc and tax, which means they can change during execution. For instance, the value of the variable tax could be initialized as 0 during declaration. Later, it could be changed according to a formula. But the tax rate is constant. The value of the constant tax rate will not change during program execution, as it is declared as final. It is time for a small knowledge check. Select the correct option and click Submit. Select the correct option and click Submit. Select the correct option and click Submit. Let us summarize what you have learnt in this animation.